Welcome to today's Explainer, where we're going to tackle a topic that literally makes or breaks your final grade. Look, I want you to imagine the Cambridge Physics 0625 exam not just as a standard test of what you've managed to memorize, but as a high-stakes game. Think of it like this. You're walking onto the floor of a casino, you're sitting down at the table, and the examiner, well, the examiner is the dealer. And if you don't know the unwritten rules of this particular game, the house is always going to win. They've designed it that way. But if you understand exactly what the examiner is looking for, the hidden mechanics behind the questions, you can flip those odds entirely in your favor. Today, we're putting our focus on one specific, notoriously tricky topic, moving in circles. We are going to decode the exact step-by-step strategy you need to walk out of that exam hall with absolutely top marks. So, let's get into it.
Here's our master blueprint for today's session. 1. The high-stakes challenge. 2. The 4-step winning strategy. 3. Moving in circles explained. 4. Real-world applications. And finally, 5. 4 essential memory prompts.
Okay, moving right into part 1, the high-stakes challenge. Now, the moving in circles topic is a classic micro-topic nestled right there in the Forces in Motion chapter. But here's the thing, it operates as a massive trap for the unprepared student. To avoid falling into the examiner's trap, we absolutely must start with an application-first approach. Before we even begin to talk about formulas or variables or super technical definitions, I want you to ask yourself a foundational question. What physical effect, measurement, or prediction actually depends on understanding moving in circles? Really think about that for a second. If you can't answer this, then all the formal language of physics you've learned is just decorative. It's just noise. It means nothing on the paper. The examiner doesn't just want to see that you can repeat a paragraph you memorized the night before. No way. They want to see that you understand why this concept is strictly necessary to explain the physical world around you. And this slide right here brilliantly illustrates exactly where things go horribly wrong for typical students under pressure. Let's look at 2 hypothetical test takers who are dropping massive points. First up, we have Alex. Now, Alex is great at the math side of things. Alex writes down perfectly correct formulas for circular motion. But here's the critical error. Alex completely forgets to explain what those variables actually mean in the specific context of the question. Boom, 0 marks for explanation. Then, on the right side, there's Sam. Sam is the textbook parrot. Sam memorized the study guide perfectly, rushes in, and quotes a physical process word for word, but completely fails to link that process to the specific physical effect happening in the exam prompt. Both of these students lose highly valuable, easy-to-grab marks simply because they ignore cause and effect. The examiner is literally begging you to connect the dots for them, and Alex and Sam just leave the dots hanging. Before we continue, subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's move into part 2, the 4-step winning strategy. So how do we avoid the tragic fate of Alex and Sam? How do we actually beat the dealer at their own game and secure those marks? Well, we use a structured system. We transition completely away from just guessing what the examiner wants, and instead we deliver exactly what the Cambridge syllabus demands from you. This right here is the ultimate, absolute safest method for structuring your exam answers. It's a 4-step sequence that is directly aligned with how top-tier students tackle IGCSE-style physics questions. Let's break it down. Step 1, identify the definition. You need to name the quantity or phenomenon clearly right out of the gate. Don't leave them guessing. Step 2, state the relationship. This is where you bring in your equations and clearly state how the variables interact with each other. Step 3, explain the underlying physics. Please, whatever you do, don't just dump the formula and run. Explain the physical cause and effect happening behind the math. Step 4, connect to application. Tie it all back to an observation, an experiment, or a real-world device mentioned in the prompt. If you structure your response using these 4 linked steps, you leave literally no room for the examiner to deduct points. You've boxed them in. The absolutely crucial takeaway here, and if you write one thing down today, make it this, is that the best answers show both understanding and application. It is simply not enough to just understand the theory in a vacuum. Memorized wording completely shatters the very second you are faced with a slightly unfamiliar question format. You know those questions that look completely different from the past papers? That's where rote memorization fails. You have to demonstrate physical reasoning. You have to prove to the person grading your paper that you know how to wield the tool, not just what the tool happens to be called. All right, part 3, moving in circles, explained. Now that we have our powerful 4-step blueprint, let's actually apply it directly to our microtopic and master the underlying physics. When we talk about moving in circles in an exam context, we are really talking about a transition. We are moving from everyday concrete examples, like a car going around a roundabout or swinging a bucket of water on a string, and we're translating that into precise, formal physics vocabulary. We need to actively describe the forces at play, the particles involved, and most importantly, the specific causes and effects of that circular motion. You bridge the gap by starting with what you intuitively know about the real world and translating it directly into the symbolic relationships the examiner is waiting to see.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to the strategy. As you build your answers, you want to always move gradually into the heavy physics vocabulary. Introduce just one symbolic relationship at a time so you don't get tangled up in your own variables. And listen closely to this part. If your exam question involves graphs, which they frequently do, especially in papers 3 and 4, you must explicitly state what the slope, the area under the line, the direction, or the overall shape means physically. If a changing slope means a changing acceleration, you have to actually write that down. Say it. Finally, whether the topic involves magnetic fields, mechanical forces, or charged particles, you must insist on cause and effect. Sing to yourself, a force is applied, therefore the direction changes. Never just list isolated facts like a bullet point summary. Connect them. Which brings us nicely to part 4, real-world applications. Let's see how all this theory builds into the final and arguably most crucial step of our winning strategy, the application. Why on earth do we care about moving in circles outside of a Cambridge exam hall? Because quite frankly, this physics governs so much more than just a pendulum swinging in a classroom. We are talking about massive industries here. Experiments, heavy engineering, transport safety, advanced energy systems, global communications, cutting-edge medical technology, and literal astronomy. The physics of circular motion governs the satellites orbiting the Earth that allow our cell phones to work. It strictly dictates the safety limits of the banking curbs on major highways so cars don't fly off the road. And it's fundamentally the science behind centrifuges used in medical labs every single day. As a student aiming for the highest possible grade, you must always be able to name at least one real situation where circular motion matters. If an exam question asks for an application, you should have one of these scenarios locked, loaded, and ready to fire. But here is the catch. Just naming the application isn't quite enough to secure full marks. You have to answer this critical follow-up question. Why does the physics help us predict or improve outcomes in this specific scenario? If you just scribble down satellites in space and rush to the next page, you're going to lose marks. You need to explain exactly why understanding centripetal force allows engineers to calculate the precise velocity needed to keep that multi-million-dollar satellite from crashing right back down to Earth. You have to justify the link between the physics and the real world. All right, our final section, part 5, 4 essential memory prompts. So we've covered the traps, we've broken down the strategy, we've translated the physics, and we've mapped out the applications. Now, I'm going to give you a foolproof revision system. Seriously, take a mental screenshot of this. Whenever you revise any micro topic, I want you to force yourself to answer these 4 memory prompts out loud. Prompt 1, what is the core idea? Your required action is to define it clearly and state one equation. Prompt 2, what changes physically? Your action here is to explain the cause and effect chain. Prompt 3, what quantity or graph shows it? Your action is to vividly describe an experiment or a graph interpretation. And prompt 4, where is it used? Your action is to give that real-life example and thoroughly justify the link. If you can talk through these 4 prompts for circular motion without checking your notes, guess what? You have essentially just perfectly drafted a high-mark structured exam answer. It really is that straightforward, guys. If you can answer these 4 prompts aloud, the topic is secure enough for your short answer and structured questions. This strategy acts as an absolute shield against those common weaknesses we talked about with Alex and Sam earlier. It ensures you never leave out a crucial variable, you never miss a physical link, and you always provide an application that makes complete sense to the examiner. It completely removes the guesswork and the panic from the equation. To wrap up our masterclass today, I want you to remember this definitive rule for Cambridge exam success. In exam answers, the safest method is definition, relationship, explanation, application. This isn't just a good idea or a helpful tip. It is the absolute core strategy of top performers. It is the exact repeatable sequence that turns a messy, confusing, panic-written answer into a clear, undeniable demonstration of physics mastery. So we return one last time to the high-stakes table. You know the traps they've set for you, you have the 4-step strategy to counter them, you know exactly how to link cause and effect, and you have your 4 essential memory prompts to secure your knowledge before you even walk through the doors. The odds are now completely 100% in your favor. But knowing the rules and actually playing the game are two very different things. When you sit down in that exam hall, are you going to let the paper dictate the terms, or are you going to take control of the table? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.